Employees have been entering and working in confined spaces for many years. Most of them return safely, but many do not. Whether you're employed in a factory, chemical plant, public agency, or service organization of a construction firm, the confined space hazards you face are quite similar. Failure to closely follow specific rules, regulations, and confined space safety standards can just about guarantee serious injury or even death. There isn't any room in confined space entry for risk-taking. Every job must be approached with a professional attitude and a methodical system designed to prevent situations from escalating into disaster. The National Institute for Occupational Safety and Health, or NIOSH, found in more than 50% of confined space accidents, the rescuer becomes the victim. This same scenario is repeated time and time again. A worker is overcome by an atmospheric contaminant, and the rescuer, being a concerned person, goes into the space to rescue the overcome worker, only to become a partner in death. There have been cases where as many as 5 potential rescuers have fallen victim during a failed rescue attempt. NIOSH also found that very few organizations provided any type of written procedures or training specific to confined space entry. Rarely had the confined space been tested for atmospheric hazards prior to entry, or had any provision been made for ventilation or safe rescue. These major factors have historically led to annual death toll of more than 300 workers. Workers just like you, with families like your own. When required to enter a manhole, vault, or other confined space, there's much more involved than just lowering down the tester and going to work. It's serious business, and you must be very familiar with the hazards you could encounter. This video program is designed to provide you with safety basics involved in confined space entry. Of course, we can't cover all the hazards or safety procedures, but we will go over the most essential safety methods. No matter how you look at it, confined space entry is a complicated matter, requiring specific procedures, so you must always follow your company's policies and procedures. Let's start with the definition of a confined space. The Occupational Safety and Health Administration Standard 1910.146D defines a confined space as any area which is large enough and so configured that an employee can bodily enter and perform work and has limited or restricted means for entry or exit. Is not designed for continuous human occupancy. By this definition, is this sewer manhole a confined space? How about this water utility vault? This tank? Storm drain? Wet and dry well? Silo? Pipeline? Pressure vessel? Hopper? Pit? Or vat? If you answered yes to all these questions, you're correct. How about this trench? Depending on the circumstance, even trenches can become a potential confined space. The very first and most basic safety rule is never, ever trust your senses. That's right. In confined space, workers will swear that they can tell when the air turns sour. Well, they're wrong. Dead wrong. There are many hazards that just can't be detected by the human nose until it's too late. Other hazards can actually play tricks on your sense of smell, lulling you into a false sense of security. Let's take a moment to review the most common confined space atmospheric hazards. Oxygen deficiency. Depending on where you live, the air you breathe generally contains about 21% oxygen. In order to safely enter a confined space, OSHA requires that the space have a minimum of 19.5% oxygen. Levels of 14% can cause difficulty in breathing or drowsiness. 12% can create an inability to think clearly. At 10%, unconsciousness can occur, and at 8%, well, you're probably history. Not only is oxygen deficiency a concern, but in certain cases, an excess of oxygen can occur, creating a fire hazard. Generally, an oxygen-enriched environment contains at least 23.5% oxygen. In this case, a spark or other source of ignition can cause a flash fire and/or explosion. Flammable or explosive gases. Many confined spaces may contain flammable and/or explosive gases or vapors. Often these hazards occur naturally from decaying paint or animal material, natural gas, chemical and petroleum byproducts, illegally dumped hazardous materials, or seeping fuel. It's important to remember a couple of important points regarding flammable and/or combustible environments. Some flammable and/or combustible vapors are lighter than air and collect at the top of the space. Others, which may be heavier than air, settle at the bottom. Common flammable gases found in confined spaces may be carbon monoxide, natural gas, hydrogen sulfide, and methane, to name a few. Remember, methane, in addition to being lighter than air, may also push out oxygen from the space, causing suffocation. Methane, also known as sewer gas, is odorless, colorless, and explosive. Toxic gases and vapors. As if oxygen deficiency and explosive gas aren't enough to worry about, in some cases toxic vapors and gases can cause injury or death, even in low concentrations. Toxic atmospheres are generally divided into two major classes: irritants and asphyxiants. Irritants are gases that in low concentration may only cause an irritation to your respiratory system, such as a sore throat or coughing. High concentrations can cause serious concerns or even death. Hydrogen sulfide, H2S, a common gas found in confined spaces, is an extremely toxic substance. As little as 100 parts per million, or 0.01%, can cause death. Exposure to certain concentrations can cause your lungs to fill with liquid, drowning you in your own body fluids. High concentrations can cause you to quickly pass out and fall. If you're not found and treated quickly, you may die. Hydrogen sulfide is an insidious gas which smells like rotten eggs. It also deadens your sense of smell so that you can no longer detect the odor. H2S is flammable and explosive as well. Asphyxiants can cause death by displacing or pushing out air you need to breathe. The most common asphyxiants are carbon monoxide, carbon dioxide, and sulfur dioxide. Be aware that any one or combination of these hazards can coexist in a confined space. Now, if your sense of smell can't be relied upon, just how do you safely test the space? Years ago, confined spaces were often tested with such items as candles, small birds, and mammals. Technology provided some early testing devices such as this flame safety lamp, alarm-only instruments, and other types of sniffers. Today, modern instrumentation takes advantage of sophisticated sensors, LED readouts, pumps, and many other improvements. The key to using confined space instrumentation is to assure that the user is very competent in the calibration, use, and interpretation of the results. Just handing an instrument to any employee to use is dangerous and should never be considered. The new OSHA standard requires that in addition to a well-trained user, the instrument must be calibrated to the manufacturer's instructions. How else can you be sure that the unit is working properly? An important aspect of the new OSHA standard is the definition of a permit and non-permit required space. The term non-permit required confined space is defined in 1910.146b as a confined space that does not contain, or with respect to atmospheric hazards, have the potential to cause any hazard capable of causing death or serious physical harm. Some examples of non-permit spaces might include ventilated vaults, open vaults, motor control cabinets, etc. The key is that these examples have sufficient natural or mechanical ventilation to prevent the accumulation of hazardous atmospheres. In addition, they also do not present an engulfment risk or other hazard. Permit-required spaces, on the other hand, defines a confined space that has or has the potential for one or more of the following hazards: atmospheric hazard, such as oxygen deficiency, toxic or combustible environments; engulfment hazard. An engulfment hazard is the potential for an employee to be trapped by liquids and/or flowable solids, such as powder or grain. Configuration hazard. A configuration hazard is represented by the shape of a space, such as a hopper, with inwardly sloping sides, and any other recognized hazard. Specific training must be provided to be sure that employees are well versed in the difference between permit and non-permit required spaces. Essentially, the permit system is part of a written program and procedure requiring supervision to prepare and issue permits for entry and work within a confined space. The purpose of the permit is to gain the supervisor's permission to enter and walk the entry team through specific step-by-step procedures to assure everyone's safety. Upon occasion, an additional permit may be required for operations which would require hot work, such as welding or cutting. Safe entry and work in confined spaces require employees to be trained in the risks, hazards, and procedures for working safely. No work should take place in a confined space, permit or non-permit, without careful pre-planning beforehand. Let's review some of the essentials we've covered so far. First, permission must be obtained to perform the work in permit-required spaces, assuring that the necessary permit was completed prior to entry. Next, employees must be trained and have a clear understanding of the hazards that may be encountered during the project. In addition, the worker must have the ability to review the atmospheric results. Also, each employee must understand his or her responsibilities for the project, including the use of trained workers, observers, and emergency standby personnel. Other procedures to take into account include the condition of on-site safety equipment. All necessary safety equipment must be on-site and in good working order. Instrumentation of a direct reading alarm type must be calibrated according to the manufacturer's recommendations and checked before use. The space should be continuously monitored during the course of the project as well. Testing and evaluation of the atmosphere should be completed by a trained, competent employee. Lines that carry flammable or otherwise injurious substances must be blocked or locked out to avoid accidental contamination or injury while in the space. Ventilation equipment must be working properly and of sufficient capacity to adequately ventilate the space. Assurance that the space has been cleaned or purged of hazardous substances prior to entry. However, be aware that purging with certain inert gases can in itself create a hazardous condition. The permits used during entry projects must be kept on file for at least 1 year after the date issued. This information could also provide valuable history on certain confined spaces that are frequently entered at your organization. If chemical products such as paints or coating may be used in the space, it's an excellent idea to refer to the Material Safety Data Sheets, or MSDS, to identify any potential hazards based upon the job being performed. The most important jobs associated with confined space entry are that of Confined Space Supervisor Observer and Emergency Standby, though your organization may decide to choose a different title. The Confined Space Entry Supervisor or Observer is the person directly in charge of the operation. They're responsible for assuring that the job is progressing safely. They'll see to it that the atmosphere in the space is safe to enter, that ventilation is sufficient for the space, and that all necessary safety and emergency equipment is available for use. The observer's sole job is to supervise the safety activities of the task, monitor the atmosphere, and assure that only trained employees are assigned to the job. In addition, they must remain in direct communication with the workers at all times. This generally will be in the form of voice or radio contact. Though if using a radio, be sure that it is certified for potential explosive or flammable atmospheres. An additional trained emergency standby must also be nearby to assist in the event of a potential rescue. Let's now talk about proper techniques involved with confined space entry. First, acquire permission. Complete the necessary permits or forms and arrange for all the necessary equipment to be on site. By the way, it's a good idea to provide dispatch with exact map coordinates in the event of an emergency. This will provide quicker emergency response when it's needed. Next, determine if there are any unplanned concerns or hazards on site, such as traffic control, contractors, chemicals, lock-blockout operations, and so on. Then determine whether all employees are currently trained for the task and have permission to be there. This includes emergency standby crews as well. The next step is to sample the atmosphere by testing the opening. You can do this by first testing around the edges or in a pick hole. Then, Open the lid slightly and test in the upper aspect of the space. Drop about 1/4 of the way down, halfway, 3/4 of the way, and on to the bottom, carefully testing and documenting the results as you go. Make sure you provide adequate ventilation to make the space safe or augment existing ventilation. See to it that the ladder rungs are safe. Certain chemicals can react with metals, corroding the ladder and making a fall a distinct possibility. If needed, clean or purge the space of any unsafe products or materials. Look around the area for evidence of illegal dumping or hazardous materials, such as an oily residue just outside the opening. Review the results of testing with all those on the project and be sure they understand any potential hazards that might be encountered before they enter the space. Be sure that employees are provided with the necessary safety equipment for use in the space, in addition to emergency rescue equipment. Remember to continuously monitor the atmosphere and remain in direct communication with the workers at all times. Confined space emergencies are no place for single-handed heroics. More than 50% of confined space deaths involve potential rescuers. Should an emergency arise, the observer will immediately summon the emergency standby to call for assistance before any attempt to enter and make a rescue. Always have all emergency numbers handy for use. If your organization uses employees to make a confined space rescue, each employee must be provided with and trained in rescue procedures, personal protective equipment, and equipment required to make a rescue. OSHA does provide for the use of outside emergency rescue services, but be sure that careful coordination is considered before taking this step. Members of the rescue team must undergo training at least once every 12 months, including hands-on simulated rescue techniques. This would generally require the use of mannequins, dummies, or people to effectuate the training in actual permit simulated spaces. Each member must be trained and comfortable with the use of self-contained breathing apparatus, as well as escape packs and ventilation equipment. Work team and emergency crew members must be trained and hold a current first aid and CPR certificate. And no matter what, no rescue may ever be attempted without the use of the proper respiratory protection, such as an SCBA, escape pack, ventilation, and mechanical hoist with full body harness. The full body harness should include the retrieval line attachment on the back, between the shoulders. Wristlets may also be used in lieu of a harness. Remember, confined space work can be extremely hazardous. And although we can't provide all the necessary training required for safe work in confined spaces, we hope this program has made you more aware of all the hazards involved. If you think about it, with over 300 deaths annually, the rules and regulations as adopted by OSHA make good sense. Testing for safe environment makes sense. The use of emergency egress equipment also makes sense. Training, personal protective equipment, permits, written procedures, and other related requirements all lead to a safer workplace for you. Thank you.